In this demonstration, I'm going to show you how to increase the disk space for a virtual machine running Linux that's using Logical Volume Manager, also known as LVM. So firstly, we will increase the size of the actual disk on the virtual machine, which in this case is the VMDK file, because we're working with VMware Workstation. Once this is complete, we'll get into the virtual machine itself and make the necessary changes through the operating system in order to use the additional space that's been provided after we increase that hard drive. So this is going to involve creating a new partition out of this newly found space, expanding the volume group and logical volume, followed by resizing the actual file system itself as the final step. It's important to note that before proceeding, I strongly recommend that you have a full backup of all your data, because entering a command incorrectly while working with the disk could potentially cause data loss. If you have a virtual machine like I have, make sure you have a snapshot first, otherwise ensure that you have some other form of up-to-date backup, and check that before proceeding. I should also note that a snapshot might not be possible until after the disk has actually been expanded. I know in the case of with VMware Workstation at least, I can't actually expand the disk while there's a snapshot in place, so the snapshot would have to come after the disk has been expanded. In this particular example, I'm using a CentOS 7 virtual machine, which is, as I mentioned, running in VMware Workstation, though these steps should work the same regardless of the virtualization software that you're using. In this case, the current disk size is 20 gigabytes, and we'll be looking to expand that to 30 gigabytes. As this method works with LVM, we will first confirm that our partition type is actually Linux LVM with the fdisk command. As you can see here, dev SDA2 is listed as being a Linux LVM, which is type 8E, which is the hex code for LVM. On the other hand, we have dev SDA1, which is just a native Linux partition, which is identified by 83, and that's just used for the boot drive. So here you can see dev SDA1/boot. So now we'll just have a quick look at the current disk space, so we can see that the majority of the space is used on the root volume. So you can see here dev mapper CentOS-root is 19 gig, and as I mentioned before, this virtual machine has a 20 gigabyte disk. So this is what we're going to be looking to expand, the root volume. Now that you've seen how things are currently set up, we'll start by first expanding the virtual hard drive. With VMware Workstation, I don't seem to have this option unless I power off the virtual machine. However, I've done this before with VMware vSphere and other virtualization options, and that allowed me to do the expansion on the fly. So you can potentially complete the whole process with no downtime required. In this test environment though, I need to power off the virtual machine first. So if we have a look at the settings of it and go to the disk, you'll see the expand button is basically grayed out. So I'll just quickly shut it down and we'll be able to continue once that's complete. Okay, so now that the virtual machine is off, we can edit the settings again, select the disk, and now these options are no longer grayed out and we can actually use them. So in this case, as you can see, the current disk size is 20 gigabytes. We're just going to increase that to 30 and select expand. And that's just going to expand the virtual disk. And all this is going to do is just change the size of the actual hard disk. So it's not going to be usable within the operating system until we go in and run some commands and actually tell it to make use of that space, which is what we'll be doing once this completes and we boot back up. Okay, so now it's complete. It's showing that the disk was successfully expanded and we must repartition the disk and expand the file systems from within the guest operating system. So exactly what I just mentioned. So we have to boot it up and configure it. So we'll just power it on. The virtual machine has booted back up and I've logged in. As we've just booted back up after increasing the space of the actual hard disk, the new space should automatically show when I run the fdisk-l command. So as you can see, it's showing the dev SDA disk is now being 32 gig. Previously I think it was showing as 21.5. So that space is actually being picked up, so we can now use that space. So what we're going to do with this additional space is create a third petition, dev SDA3, then we'll be able to go from there. To first use that additional space, we're going to have to create a new petition. So we're just going to use the fdisk command for that. And specify fdisk dev SDA, which is the primary disk of this virtual machine. It's the only disk that it currently has. If you haven't used fdisk before, you can press the M command and it's just going to show you everything that's available that you can do with it. So that'll give you a good idea of how it all works. We're going to press N first for new. And we're going to want to press P for a primary petition. And this is going to make it the third one, as we already have two. It's worth noting here that it does note that there's already two primary and that there's two free. In total, you can only have 4 primary petitions, so if you already have 3 and this is going to be your 4th, I'd suggest probably making it a logical petition if needed. Alternatively, you could add in a new virtual disk to the virtual machine rather than expanding the existing one, which is what we're doing in this example. I'll put some links in the description on how you can do it the other way. But for the time being, we do have the space, so we're just going to continue on with extending the existing disk. So yep, we're going to make this petition 3, which is the default option, so I'll just press enter. And now it's asking where I want to start this petition, so we're just going to press enter. So by default, it's going to use the lowest position available. And then for the last, it's again going to give you the last available option, which is fine because we want to make use of all the disk space that we've just added. We're not going to do anything specific. So now that that's done, we need to set the type of petition. As you can see above, that's done with the letter T for change a petition system ID. So press T, and it wants us to select the petition that we're going to set. So we're going to use 3 because we just created our new petition as number 3. And now we need to give it the hex code. So there are a fair few hex codes, as you can see here, by entering the capital L. We want to use 8E, which is LVM. So as you can see, it's changed petition Linux to Linux LVM. Now we're basically done here, so to save all the changes, you just need to press W and then enter. So that's going to actually write the changes. If you don't actually press W and write the changes, everything that we've just done previously in fdisk won't actually be saved, or it won't apply at all, so make sure that you do that. So you might see a warning here, like we do, basically showing that the petition table can't be updated and you might need to reboot. So after using fdisk to create the dev SDA3 petition, I did have to reboot the virtual machine first. That was basically required because I wasn't able to write the changes to the petition table while it's in use. So you can try and get around that with commands like partprobe or partx, but in this case this is just test environment, so I just rebooted it. So that's all for petitioning. So just to summarize, so far we have created the dev SDA3 petition, which is using all of the unallocated space that we got from increasing the disk in VMware Workstation. So with this new petition, we can use the pvcreate command to turn it into a physical volume. So we can do that with pvcreate and then just specify dev SDA3. So that's successfully created physical volume dev SDA3. And we're going to use this new physical volume to increase the existing volume group. So we need to confirm the name of the volume group that we actually want to add it to. So this can be done with the vg display command. So as you can see, the first field VG name is just CentOS. So in this case, our one and only volume group's name is CentOS. It's also worth noting the free physical extent and size field is currently 0, which is because it doesn't have any free space in the volume group, which is why we are going through this process. If you had free space here already, you'd just be able to use LV extend and increase your logical volume. But we don't, so what we're doing is creating that physical volume and then adding that into this volume group so that we can then extend the logical volume. So in this example, as I mentioned, CentOS is the volume group, so we're going to use the vg extend command on that volume group and add dev SDA3 in. So that's done by just specifying vg extend followed by the volume group name, in this case CentOS, followed by the petition that we've created, so that's dev SDA3. So as you can see, volume group CentOS successfully extended. Now if we run the VG display command again, we can see that the free space is now 10 gigabytes. So that space is now in that volume group, and it can be assigned to logical volumes that exist inside of that volume group. So if we run an LV display command, we can see the logical volumes that we currently have. So by default, we just have one for the root partition, which is what we're going to be expanding, and one for swap. So just ignore the swap one, we're not going to be using that. But it's important to note that both of them show the volume group name as being CentOS, which is where we added the physical volume into. It's possible that you might have multiple volume groups with logical volumes inside different ones, so just make sure that you add the physical volume to the volume group name which the logical volume exists in. So for instance, dev CentOS root is part of the volume group CentOS, so that's why we expanded the CentOS volume group in this case. So now we'll run a pb scan command, and that will just show us all the physical volumes as well as the volume groups that they exist in. So you can see both dev SDA2 and dev SDA3 are both in the volume group of CentOS, but dev SDA3 does show as having 10 gig free because it's not yet in use at the moment. So now that we have this extra free space inside the volume group, we can go ahead and expand the logical volume, which in this case is dev CentOS root. So we do that with the lv extend command. So we can either use all free space in the volume group, so we could expand dev CentOS root by the full 10 gigabytes, or we could just specify, say, 5 gigabytes, and then we would have 5 gigabytes free that we could assign either in the future or to a different logical volume which might exist inside that volume group. So we use lv extend -L, which is basically saying we're going to extend by the amount specified. So plus 5 gigabytes, dev CentOS root. So as you can see, the size of that logical volume has been increased successfully from 19 gig to 24 gig, so we've increased it by 5 gig as specified. So now if we run an LV display again, and we have a look at that root volume, we can see that the LV size is now listed successfully as 24 gig. And if we run a VG display, we can see that the free space is only 5 gig because we've taken 5 gig out of the CentOS volume group and assigned it to that root volume. So if we run a df-h again, we can see that the space isn't yet available for use. It's still showing the root partition as being 19 gigabytes in size. And the reason for that is that we haven't yet resized the file system, which is the final step. The logical volume's been successfully increased, and now the last step is to resize the actual file system which is running on top of that. So in this case, we do that with the resize to fs command and specify that root volume, which is dev CentOS root, and that just performs an online resize of the file system. So now if we check the space, it shows as 24 gigabytes for that root volume, so it has successfully been expanded. I should also mention that in this case, I created the file system as ext4, which is why we were able to use the resize to fs command here. However, in CentOS 7 by default, it does use the newer xfs file system. So if you did have an XFS file system and resize 2fs doesn't work, you would be able to do this pretty similarly. You just use xfs underscore growfs and then specify that root partition, so it would work like that. So just to summarize what we've done, the virtual disk of the virtual machine itself was first expanded. We then used that free space to create a new LVM partition with fdisk. We turned it into a physical volume with the pb create command, and then extended the existing volume group over the top of the physical volume using the vg extend command. Then we extended the logical volume with the lv extend command, and then we resized the file system to take advantage of that newly added space to the logical volume, giving us extra usable space as shown by that final df-h command.